In Module 14, we will cover Chapter 15 in the textbook. Let's talk about standard library containers and iterator. So what is standard library? Standard library actually is STL, Standard Template Library from C++. In the Standard Template Library, we include many different useful data structure template library we can use. For example, vector we heard before. And we have queue, stack, map, set. So all the different data structure, we say they are one kind of containers because they will store different kind of data type as long as you specify at the beginning. So the template we know before we implement template function. That means a function can be adopt different data type. So the same thing, our standard template library, all the library, no matter which data structure you use, you just specify the data, the object type you want to store. We can respond to that. So all the data structure we call they are one kind of container. So that's why this week we talk about standard library containers. And also the other important thing is the iterator. Each sequential container, they store data one by one. And we can use in the iterator to access the container element one by one. So in this class, we will focus on vector sequential container. And the other kind is map, that's associate container. So the first thing in this video, let's talk about what are the standard template library. The standard template library defines powerful template-based reusable component that implement many different data structure and algorithm. So that's important. You can see they are template-based. That means we can adopt different data type for our data structures. So in the standard template library, we implement all different kind of data structure. So that's your next course, COMSC165 you will take data structure and algorithm course. We will focus on data structure mean how you will store the data in different structure. So if you want them to be one by one, you can be array, you can be vector, you can be list. So that's what we call that they are sequential container. But sometimes your data structure, you want to have different order. You want to first in, last out, or first in, first out. So according to how you will access data and how you will store the data, how often you modify your data, we have different data structure in the STL library you can use. They can adapt for all different kind of data type. So in this chapter, actually, we will quickly to give you the all-over introduction about the standard library. The first thing, of course, we have the container. That's earlier we say they are template-based data structure. And also, most of the container, we can use the iterator to go over the element from the container one by one. And also in the STL library, we include many different useful algorithms. Because we can do the search, we can do the searching, we can do the sorting. We also can merge the data, we can remove the data. So that's all different algorithms. In this class, we will focus on how to use those containers and how to use the iterator to access the elements one by one. We have a lot to talk about in this chapter. So here I will only focus on a couple important data structure we will go over. Actually, you already see array we introduced before. And we also introduced vector before. But in this chapter, we will talk about even more. And in the reference reading, I have the list to help you to refer to. And I will choose one associative container map for the example in this week. So in this class, we will focus on how to use those data structure, how to include STL library so we can create different data structure objects. But we are not focused on how to implement that. In your next class, actually in our COMSC165 you will learn how to implement all the data structure. You will learn how to implement dynamic array, static array, queue, stack, map, binary search tree, and graph. But here in this class, we will focus on only how to include the STL library. So the first thing, let's talk about what different kind of container we have in STL library. So according to how you will store the data, we have 4 different kind of container. The first one, sequential container. So that's you see before about the array, vector, or list, or deck. So when you say the sequential container, that means your element, or you say each data, they are one next to each other. Okay, remember array. You can have, they are actually one next to each other, right? But you can use the index to access that. About the vector, this week we will talk about more. So the vector, basically, they are also the data one next to each other. You can use the index to access that. You also can use the push back to add the new element at the end. So then you have the other two is we call list. So the difference between list and the vector is list, they can be pushed to the front or pushed to the back. They can access front, they can access the back. Then you have the deck. Deck actually is a queue. Supposedly they are also one next to each other, but they can access from the beginning and the end. But no matter which one, they are sequential container because they are one next to each other. So the sequential container, we say, then you only have the data you store one by one. But then we have the second one we call ordered associative container. That's the set and the map. So we will talk about map in this class. So what means they are ordered associative container? That means actually they do have an order. But this order maybe is not according to the data one next to each other. They maybe have the sorted order, or they have their insertion order. And they are associative container. That means when we talk about the map, you will see the map actually you have key and the value. So before, when we have the array or a vector, we only store value, right? Because for example, you have string vector, you have string array, so you store the string value. And you only can access with the index. But for the associative container, the map, we are not using the index, the integer to access our value. We can use any key. So this key can be any data type. For example, I can using the student name to access student's phone number. So that's the order associative container. We will introduce map in this class. So on the other thing is you can have order associative container, or you can have unordered associative container. So for the unordered set or unordered map, you just need to know we have those things, but I don't introduce in this class. So the last one also is important. They are also is the container from the sequential container, but we adopt it. So that we have the stack queue or the priority queue. So too simple to say what is the stack. The stack, the data, they are still one next to each other, but they cannot be accessed using the index. They only can access by the push and the pop. So here we say the push, that means you can add a node. So pop, you can pop a node. For the stack or queue, they only can using the push and pop to access the data or insert the data. And the stack, they will follow the order is first in, last out. So that means if you are the first one push in, actually you will be the last one pop out. So the same thing queue, they will be the push and the pop as well. But the queue will follow the first in, first out. That's mean the first one I push will be also the first one I will pop out. So that's why in the standard template library, actually we have so many different useful data structure we can use. So basically they have 3 different types. They have the sequential container that we will focus on in this class. And I also introduced the order associated container, the map, we will talk about in this class. Unfortunately, we don't have too much time to talk about the container adapter, like the stack and the queue, and the priority queue. So one thing is, you just need to know, when we talk about the stack, it's just like the first in, last out. And the queue is first in, first out. You see many example queue in the real world. So like you need to wait in line to be served. So that's the container we have. So here is the list. You will see all the STL container classes. So focus on, in this module, we will talk about array, vector, and the map. So for other example, of course, you can go see in other container, we also have that. But we are not focused on the order set or map. And also the container adapter, you can see stack, queue, priority queue. That's the order they will follow. So here is all the STL library classes we list here. So why we all put them together? Because all the STL library, they have some common member function. They all have that. So that's why here, let me introduce you those common member function they have. They all have default constructor. And also because the most STL library, they use the dynamic memory. So that's why they have copy constructor. They have destructor. And you can empty all the data. So you can insert an item into the container. You can know the size for how many elements there are in the container now. So you need to be careful. The size is different from the capacity. For example, sometimes your vector, you have specific capacity. That's like the array capacity. But here the size we talk about is you have capacity of 10, but you only insert 4 data in there. So the size will be 4. And also they have the copy operator. So that's what we call the assignment operator. So you can assign one vector object to another vector object. Why they need that? Because remember, be careful, they are all the dynamic memory. So if you have a pointer to assign using the equal, they will refer to the same object. So that's why we need to override that operator. And also, did you remember, you see all those operator overloaded function? Right, so the assignment operator, the less than equal, those comparison operator, right? So right, so that's why here we learn how to implement those overloaded operator for our user-defined class. So the same thing, for all the container class in the STL library, you all need to have those operator defined. So that's why we can compare to vector or to map. And continue with that, you see they have the swap function. And the most important thing I want you to see here, they have the begin, they have the end function. That means you can get the first element and the last element. That's important is later, our iterator, we need to use that. And also you can have the begin and the end, they mean they are not constant pointer to refer to that. So that's why when you try to update the data in the container, use the begin and the end. Otherwise, use the constant begin and constant end. Or they have reverse order, the reverse begin and the reverse end, and the constant reverse begin and the reverse end. That means they are using the constant pointer to refer that, and the reverse, they will do the from the back to the beginning. And you can erase a node, you can click all the node. That's important member function in all the container.